Until now, the lean and very efficient C++ program DenseNN from the EigenNET project has been used to train deep learning structures with parts or complete training dataset. But what if additional training data is only available to you after training? This is not longer a challenge, as DenseNN can be trained iteratively with version 1.10. This means that the deep learning structure can be retrained as often as desired with the new training data. In this video I will show that iterative training only depends on the condition of a function argument, so it's quite simple. I will demonstrate this using an R script, but it is clear that DenseNN can also be integrated into Python. So welcome to the video Iterative Training of a Deep Learning Structure with DenseNN. This is a R script that integrates the C++ program DenseNN. If you are familiar with the video Training Dense Networks with the C++ EigenNET project, you know that integrating DenseNN is quite simple and does not pose any challenge. The R script display iterative training process is only used to visualize the training progress and has been excluded for reason of clarity. The R script, as well as the DenseNN, can of course be downloaded from the GitHub repository github.com/suprenum.de DenseNN. And again, you can do all of the following things with Python. Okay, let's get started. First, I will integrate the scaling function and the R script for the graphical representation and set the R working directory to the binary directory. For this example, I will use the MNIST dataset again, which needs to be processed as described in the video above. I won't go into this part any further, but splitting the training dataset will be interesting for the iterative network training. In this section of the script, I divide the entire MNIST dataset into 6 subsets and save them as a CSV file. This will then be my sample dataset for iterative training. This will take a moment. And one by one, the 6 CSV files for iterative training with the MNIST dataset will appear. Now, the deep learning structure is trained for the first time. In principle, you already know the network parameters, and I would just like to highlight the weight initialization method Hey. You will see the difference in the first iterative training. The training takes a little time for the first 10,000 datasets and the 115 epochs. And is finished after about 95 seconds with relative good accuracy. I will display the network quality graph and then move on the iterative training. I divided the MNIST dataset into 6 datasets and used one of these datasets for the first network training. This means I still have 5 datasets left for iterative training. The iterative training takes place in a for loop and depends on the parameters start and end. End correspond to the number of splits, and start is set to 2 because one dataset has already been used for training. The file name corresponding to the loop run is specified here, and the function argument weight initialization is set to iterative. The remaining arguments are kept. This means that the network parameters, bias and weights from the previous training session are loaded before the network training session and used as starting values for further training of the network. I'm performing the iterative training, which of course takes time. What you will notice is that almost continues from the network quality of the first training and is improved by the following trainings. And that from the second iterative training onwards, the specified 150 epochs are not longer used for training because the early stopping function takes effect due to the min-delta argument. This means that in this example, additional training of the network improves the network quality, in this case, to well over 19% in a shorter period of time. This is also clearly illustrated by the graphics. So far so good, but now the trained network has to be tested with the test data. Of course, the test data has to be made available to the network in a suitable structure, which I have already done with the processed mnist test file. I run the test and look at the prediction in tabular form. Here's the comparison between true label and predicted label. But since there are 10,000 data points, this assignment is shown here as a table and in two relative tabular overviews. The overviews may indicate a need for improvement, but this is not the topic of this video. And that brings me to the end of the video. I hope you have realized that iterative training of a dense deep learning structure is easy to perform with dense-NN. By adjusting a function argument, the network can be retrained as often as desired when new training data are available. Isn't that an interesting feature to try out dense-NN or use it directly for your own project? I hope this is the case and say, see you next time.